So now we're going to talk about what I think is, of course it's closer to home, me being an SE and an old route switch guy. We're going to talk about the routers and what they can do. One of the things I do want to bring up is what a router is, why we need them, and then we'll talk about the other capabilities of them. And I want to talk about bandwidth and things like that, because routers connect dissimilar networks, but routers also connect. If I have a headquarters location and I have big offices here and a data center and I have all of my bandwidth and everything going here, this is really cool. And I have switches inside of here that are connected to bigger switches. And when I want to connect up to a branch office out here where I have employees, I have to connect up. I can't just run cable across there and everything. I have to get a service through a service provider. It's called a WAN. Private service is called a WAN. So I have to have a router, and I connect it up across the WAN and put another router there. And then they'll put a switch in here, create a LAN. So in essence, what's a WAN do? Connects LANs across geographic distances using some kind of technology. That's what a WAN does. The characteristics of a WAN are significantly different than a LAN. If I put switches in here, I have gigabit Ethernet, 10 gigabit Ethernet here in my data center. Once I put that in, it's mine. Big bandwidth. Big bandwidth, big pipes. If I go to a service provider and I want to connect up, what do those pipes look like? Over here I got switching, I got big pipes over here. What's my pipes look like? Are they as big as this? Are they even close to as big as this? No, no. Small pipes. The ratio might be considered, and here's how I use it for customers. Again, business leaders who don't know a LAN from a WAN, from a RAN, from a whatever. I tell them, here's the relationship in bandwidth that you may just think about. And this is a fair analysis or a fair example. Have you ever seen where they have these big fires, where these fire departments, a 7-alarm fire, these buildings going up in flames, and the fire departments pull up and they got these big hoses, big 3-inch hoses, and they're sitting there and one's backing the other guy up and they're squirting water up on there? That's in the LAN. That's the bandwidth you have. You've got all this pressure, all this bandwidth. Have you ever used a drinking straw? That's a drinking straw. And that's about the ratio, folks. And the problem with this is if I wanted more, guess what? Every month, the service provider gives me a present called a bill. He sends it to me. The bit more bandwidth I want here, the bigger the present is. It costs me a lot of money here. It costs me a lot of money. It really does. So we have to really manage what goes across that. We have to manage what goes across that. And that's what we call QoS, or prioritization, in our routers. Our routers guard this, and they're the ones who who say who can go across and who can't. And these networks can get very, very big and very, very complicated. I could have hundreds of sites out here all connected on the same WAN. Now it might physically look like this, but I might have these logical tunnels that go here and go here and go here and go here and mesh up to where these people here can send traffic directly to this side or this side or this side or whatever. And inside of our routers, that layer 3 guy that we talked about, remember when I drew up this example of layer 2 people and the layer 3 guy? The layer 3 guy is in charge of finding out which is the best possible place to send this information. And he uses something called routing protocols. To do that. A routing protocol. A routing protocol only happens inside the routed network. All the routers talk about it. So if I add a new network, if I add a new VLAN over here, let's say I add a new VLAN. That's a new network. This router is aware of that network. Are these routers aware of it? No, not yet. No. So what I've done is I've actually done this on that router. I've added a new layer 2 guy, a new route, and this guy's job is to promote that to all these other routers, to tell them, if somebody asks you about this new network, it's over here on me. Here's where this new network is. That's what routers do, router protocols. You know, we have a lot of different routing protocols. RIP for small networks. We have OSPF, Open Shortest Path First. These are standard protocols that any router can run. Any router can run. There's the biggest form for the biggest networks is actually called BGP, Border Gateway Protocol. And that's for big networks like the internet. That's what drives the internet. All the routers running the internet run BGP. And the tables are huge for that. It takes a lot of memory to manage all those tables and everything for BGP. Cisco has its own proprietary protocol. It's called EIGRP, Enhanced Interior Gateway Routing Protocol. A lot of letters there, and a lot of words. It's the best of a couple of these, right? It's the best of RIP and it's the best of OSPF, all in one. It's almost a plug and play, to be honest with you. It's really cool. And the cool part about it is customers like it, used to like it a lot and still do. And if good thing about that is it's proprietary to Cisco. So if they're running EIGRP, guess who their only vendor for routing is? Cisco. Kind of nice. What's our market share here in these routers? What's our market share? 70 plus, close to 80, depending on where you're at. Matter of fact, at this edge, at these branch offices, we're closer to 80 than we are 70. I promise you that, if we're not already over 80. This edge router, this branch router, we're really, really good there. And I'll show you why here in just a second. But we own this market. We really do. And people have tried for years and years and years to get in there. How do you think Cisco has maintained the capability and their market share over these many, many years at that edge? Do you think we just route faster? You think that would do it? No. We have to innovate there. We have to make our routers do more than just route. We're going to talk about that. But this is a WAN. Now there's other ways that you can connect up. What if I used another network called the internet? Where's the internet go? Where's the internet go? Everywhere. Yeah. It's a cloud. It's the second global network. The second global network. What was the first global network? PSTN, Public Switch Telephone Network. It was the first global network. The second global network is the internet. That means that if I connect to the internet, notice that when I buy a circuit from the service provider, he's saying I'm connected directly to somebody. Directly to somebody. When I connect to the internet, what do? What's my service provider do? He just connects me to the cloud and says, go where you want to go. I can do www.cisco.com. I could do www.ibm.com. I could do www.anything. I can go anywhere. And that's why it's a little cheaper, right, to just connect. Could I connect my business through the internet? If I connect my business to the internet, could I connect this side of the business to the internet and run traffic that way? Yeah, it's called a virtual private network, VPN. Now we're running it across the internet. What do we have to do? What's one of the requirements we'd want to do there? Security. So we have to have some kind of encryption to encrypt that tunnel all the way through here, right? So it's secured. So maybe a requirement of that router might be to have that encryption, a piece of hardware. When we talk about SDN, when you talk about software-defined networking and everything, one of the things that we found is as traffic goes through a box, you can only do so much in a processor so fast. Encryption. That's where hardware chips come into play. That's one of the, maybe a negative of software-defined networking that we may run into. But that's a VPN. VPNs come in two flavors. They can be site-to-site or remote access. Could be Eddie right here. Now, if Eddie has software on his PC and he launches that VPN client and goes back through the internet to this router here, that's called a remote access VPN. How many of you have CVO? CVO, they send you a router, right? They put a router out here. That creates a tunnel, and that's site-to-site. That's site-to-site. Your router encrypts everything for you for the entire site back in. That's the two different ones that you have. So you have remote access VPNs, site-to-site VPNs. Site-to-site could be from home with the CVOs, could be with router business to business. The benefit of this is cheaper. You may even get more bandwidth, right? What do you lose with VPN? What do you lose?
I mean, speed, because there's always extra headers.
No, probably not that. I can get a lot more. Like I have my internet connection is 25, 20 down, 5 up is what I get where I'm at, and so I'd have a lot more bandwidth than I would probably pay for it like this on this. So, what do you lose?
It's limited to access of the...
Might be limited of access. Think about QoS. Am I guaranteed anything here? No. So let me ask you a question. So if I was sitting at home and I use Time Warner Cable, and I called Time Warner Cable, I go in and I do, I try my VPN, it doesn't work. I try to go to Cisco.com, it doesn't work. I look and it looks okay. I pick up the phone and I call Time Warner Cable. And I finally get through to maybe a human, which if it's possible. And I get through to somebody and I say, I think my internet's down. Really? Wow, don't see any service outages in your area. I can't get to Cisco. Well, do me a favor, open up a browser. I open up a browser. Did it go to your home page? Yeah, it did. Can you type www.google.com? Yeah, I can. And it comes up. What are they going to say to me? Yeah, exactly. Have a great day. Thank you for calling. Problem's not mine. Sounds like Cisco's got some issue, right? Support, but you lose quality of service. If I buy bandwidth here, I get a guaranteed bandwidth. I go to a service provider and I tell them I want 1 meg or 2 meg pipe between this site and this site. I'm guaranteed that. Am I guaranteed anything here? No. I'm not even guaranteed a firm handshake or a thank you when I call them. That's the truth. I'm guaranteed nothing. Now we can run, we run voice and video across here. That's great. But boy, when we do it here, that's why those CVO routers. They'll put voice in front of data at your house with that CVO router going into the internet. But once it gets there, we don't know what happens to it until it comes out the other end. So there's no real QoS there. We just try to kill it with bandwidth. It works most of the time, but there's times when the internet has slowed down. There have been times that it's been documented how the internet has slowed down, actually stopped in some cases. There was like a 13-second window that was documented about 6 months ago where the internet froze on the east coast of the U.S. Not long ago. Yeah, froze. That's kind of crazy. Think about that. What if you were doing a video across there? What's going to happen to your video? It's going to freeze. It's dead. The connection's going to die. It's going to time out. Guaranteed. Yeah. For 13 seconds, we don't have patience on the east coast of the U.S. It's dead. Yeah. So what you gain in some areas, it's going to be a combination of all these things that the customer's going to have. We're going to go to a service provider and we're going to buy a service called MPLS. What's MPLS stand for? Anybody know? Yes, sir. Multi-protocol label switching. Thank you very much. It's a service that they can give you, and it's one of the sweetest things in the world for Cisco. By the way, Cisco actually created this technology for our service providers. We're actually the fathers of MPLS back in the mid-90s. Mid to late 90s, we created the theoretical how MPLS would work. MPLS is the ability for a service provider to give you a pipe, and I'm going to kind of erase some of this, give you one pipe between here and here, and you can then purchase bandwidth based on your requirements. So from this site to this site over here, what are 3 different types of information I want to push across that network? I'll give you the first one, data. Just regular data, right? Regular data. The characteristics of data is it's just got to get there, but it's probably a pretty significant part of my entire pipe. So I might go to my service provider and say, I want, out of this 2 megabits per second of connectivity, I want to have 1 megabit per second of that to be data. I don't care how, if it gets there fast, just give me a full meg of data. So I'm going to take half of that. And he's going to charge me so much for that. He's going to say, okay. And when I put data inside of that network and send it to him, he's going to put a label on that data that's, Eddie's guaranteed a megabit from here to here. It's just got to get there at some point in time. Right? And he's going to charge me so much for it. What's another thing I might want to send across this network? Voice. What if I want to send phone calls across here? Voice. What the characteristics of voice is a little bit different. It's smaller. Don't need as much bandwidth, but it's got to get there quickly. Got to get there real fast. Right? So I'll say, guess what? I want to have, let's say I want 256K for voice, so I can send so many phone calls across there. And I go to the service provider and I say, I want to put voice across there, but here's my different characteristics. With MPLS, they can say, okay, I can guarantee those services for you in my network. I'll guarantee you those 256K that go across here. But because you want it to get there fast, I have to do some really cool things in my network, and I'm going to actually charge you more for that 256K than that 1 meg. But now I know if I send voice in there and give it to him and say, hey, it's voice, he's going to put that label on it in his network, and as it goes through, it's going to get treated fast and quick all the way through, and it works. Maybe video's next. Maybe I want to run video. Maybe I want to run a video stream across here. I want to take the remaining 768 that I have, and guess what I want to do with that? I'm going to go to him and I'll say, I'm going to run video across here, but I want to make sure it works because I'm going to have some big business leaders using this. This is going to be part of my business process, so it's got to work. So I want video. What's the characteristics of video? Same as voice, maybe a little more so in some cases, and it's bigger bandwidth, 768. So now he's going to be able to charge me even more for that and give me that. But am I going to be able to guarantee my work? It works? Absolutely. I can now push QoS that I could only do in my network here, and I could only do in my network here. I can now push QoS all the way through his network. MPLS is the greatest thing in the world for us, trust me. I've been in SC for a while selling voice. When we used to sell voice across older technologies, the term sucks was born. Through all these other technologies that we're doing, frame relay, this, that, and I mean, it was brutal for us.
So what's going to be the difference between that and a T1? Because T1 you're guaranteed.
T1 you're guaranteed and everything, but why does a service provider not want to give you a T1? Why do they, how a service provider is going to get you out of a T1 here is the same way that Talbot sells clothes to my wife. If I go to, let's say all of this adds up to $725 a month, all these costs. I go there and I say, you know what? The heck with this MPLS and all this. Just give me a T1, 1.5 megabits. What's he going to charge me for that? Double that. Why? Why does a service provider want to get away from T1s? Yeah. What's the job of a service provider? Let's just step back 1 second now. I'm sure you'll figure it out. You're smarter than me. You'll figure this out. What's the job of a service? How does a service provider make money? They sell services. They sell bandwidth. In this case, traditional services, bandwidth. Let me give you an example. Maybe I can get you closer. Yeah. Yeah. Think about this. What was the first way we connected to the internet? What was the very first way you connected up to the internet? Dial-up. Now, when you dialed up, so you go to a service provider that had dial-up, AOL or whoever it is, and you go to AOL and you signed up and you paid them $19 a month, whatever it was, for your dial-up. And as soon as you did that, they said, here's your modem number. Do you think that they put a modem in their network and put your name on it? It was just for you?
No, sure.
They sold that same modem number and that same modem type 20 times. They sold it 20 times. What's the job of a service provider? Sell the same bandwidth over and over and over and over. That's their job. That's their job. Why do they not like dedicated T1s? We love it. They can't oversell it because when I put that in there, I have to reserve it. And if you're not using it, at 2 o'clock in the morning, I've got that bandwidth pinned up for you and I could have sold it to you. They want to sell the bandwidth over and over and over.
So MPLS, they can oversell it.
MPLS, they can oversell it because you know what? It's like everything else. It's the Las Vegas kind of thing, right? The odds are you using your full bandwidth, every customer using their full bandwidth at the exact same time, slim and to none, and slim's walked out of the building. So guess what? I'll oversubscribe my bandwidth 1 to 1.5, 2, 2.5 to 1. That's what I'll do. And still be able to provide that service, guaranteed service, so I can get your money at a premium, what I consider a premium cost, and oversubscribe it. That's the reason that they do this. And MPLS, the beauty of MPLS is it's global. Got some people from Perth, Australia, on the west coast of Australia, opposite of Sydney. Probably smarter people there. Right? Yeah. All the smart people on the other side live in Melbourne. See, I'm trying to help you out there. So if I wanted a circuit from Raleigh, North Carolina, I could go to AT&T and say, guess what? Or several service providers and say, I need a circuit because I'm opening an office in Perth. And they can actually give me MPLS. I couldn't do that with frame relay. Frame relay would not work, trust me. You couldn't take frame relay, an older technology, and have one service provider feed to another. I tried it, folks. I tried it many, many times. And it was nothing but the headache. That's where the part of this bald spot came from. Really. Well, you think about this, a SIP network. What's SIP? The term here, SIP, came up. What's SIP? Session Initiation Protocol. Where's it coming from? Who's it come from? SIP is being able to take a traditional T1 a PRI that we might use for voice and uses IP type technology behind it for that. So yes, in this one delivery mechanism, if I want to go to that same service provider, he'll just add more bandwidth and say, I'll send your SIP trunks in there too.
Okay, so
Yeah.
would you need an MPLS network to have
No, absolutely not. You certainly wouldn't. You certainly wouldn't. But could it be delivered on the same physical wire? Absolutely. Absolutely. Yes.
How will check that the guarantee that this 1 megabit per data is
Because inside of the first router, when I send that, what he's going to do is he's going to say, when you send me this IP address, this network, I'm going to expect that that network is your data network. So he's going to say, you're going to work with him and say, anything that comes to you at 10-10-10 network is my data. So in this local router, all my data that I send across there is going to come to you in this IP form. And then he's going to, at his first router, he's going to send it into his network. The first router, the first switch or router he has is going to put that label on it and send it through the network as fast as possible.
how they achieve the guarantee that I'll always have
If it's oversubscribed,
What if everybody's hitting it at once?
you know what?
Subscribe.
If it is, what's the chances of that? And again, the chances are zero for that, really. Why? Because not everybody hits enter on their keyboard at the same time. Nobody's going to do that. They've proven it over and over and over. Yeah.
But then what's the difference between the T1 and this one?
The T1 is I physically take a 1.5 meg out of service for everybody else and give it to you.
What's the abbreviation of this T1?
T1 it's actually a transmission layer 1. It's actually 1.5 megabits. It's the equivalent of an E1 in Europe. So if you hear T1, E1, it's the way we divide it up. We can talk a little bit more about that in telephony. But in essence, it's 1.5 megabits of connectivity that was generally used to support 24 phone calls and voice. But what we did is we took the dividers out and we just use it for data. The thing about it is once I put it up, nobody else can use it. MPLS is great for us, folks. It is really, really, really good for us. Yes, sir.
How widely is MPLS being adopted?
Oh, it's probably 70, 80%. 70 or 80% at least.
Individual companies using it as well?
Oh, absolutely. Yes, yes. From a service provider perspective, if you're not doing MPLS, you are so far behind you're probably, still selling rabbit ears for TVs kind of thing. And so all the service providers are using it, and all of our customers are using it. All of our customers are using it. Does that make sense? This is a WAN. The reason I go to this detail about this is as a consultant, as somebody who sits sometimes beside a customer. I was at a customer who had an RFP out, and I was there doing something else, and they said, well, we've got some partners coming in, and the RFP was for WAN services and all this, and they just asked me to sit in on it just so happened that they were having all the people in that day. And they asked me to do that, and I was there. I was kind of done. I'd like to have got on an earlier flight, but I said, no, I'll stay till the end of the day. So I checked out of my hotel. My flight was originally, I could have moved it up earlier, but I didn't. And so I sat, and 3 partners of Cisco came in. And 3 people, 2 of the 3, created new technologies right in front of my eyes. Right in front of my eyes. Now here's where the technologies. Service providers we call this MPLS, but service providers actually put another couple of letters on the back. VPN. We've talked about what a VPN is, security and all this, that, and the other, site-to-site or remote access, and it requires encryption for us across the internet. That's what we believe VPN is. So, this person happened to be in healthcare. They were transmitting secure documents across from site to site. So, in the first session, when the first partner came in, they said, we're going to use an MPLS VPN. Now, for the service provider, it is a virtual private network. They are selling a part of their network to you, so that you get a virtual part of their network. That's why they call it a VPN. My question for you is there any security in that, any encryption? No, natively there's not. You know what the difference between my traffic and your traffic on their network and this VPN network is? What's the difference? 1 tag. It's called a customer tag. In MPLS, you can have up to 7 tags on all your traffic, depending on the characteristics of what the person wants to give you. The first tag they have is a customer tag. That's the only thing. There's no encryption in it. If I was in their network, I could actually look in there and look at your data if I wanted to. Just like I used to be able to listen to your phone calls when you used to call, if you do that. So this customer of mine, they said MPLS VPN, and he just automatically asked, he says, well, I've got a lot of confidential records and everything. If you're giving me an MPLS VPN, then you're securing my transmission across there. Yes, sir, we are. It's exactly what the partner said. Yes, sir, we are. And I'm sitting there, my jaw probably dropped. And I said, Can I just ask a question here? I'm just curious. So you're saying that you're encrypting their traffic across. Sir, it's an MPLS VPN, virtual private network. It is encrypted. We encrypt all of our customers' traffic. I said, you really do it? And I knew they didn't. I said, is that an additional service you give to these people? It's built into the system, sir. It's a VPN. And in my mind, I said, as soon as you get your little butt out of here, you'll never get this deal if I have anything to do with it. They were kind of belligerent to me, but they didn't listen and they didn't understand their technology. So they walked out. Next person comes in about a half hour later after we'd had the discussion. I did a little whiteboard. Showed the customer what I was talking about, and he goes, oh my God, those people will never get my business. Next person comes in. Almost the first question, can you explain to me an MPLS VPN from the customer? Well, it's a... Hang on. Can you explain it to him? They had their engineer. The engineer goes into all this detail. After he goes through his yin or yang, customer asks him, so my information is going to be encrypted? Yes, sir, it is. I almost fell out of my seat. The second time. Again, creating new technology for our customers and everything. The third person got it. No, sir, it's not. But if that's a requirement, we can actually do that at an additional cost. I'd have to do this and all this, but we can do it. It is capable. These service providers can encrypt it. Absolutely, can do the encryption if you want them to. Probably cheaper for you to do it yourself, but that's okay. There's a big difference in this. And from that day on, I said, every time I touch about WAN and everything, I'm teaching this. Just so we know about it. Just so we know about it. VPNs are the most, MPLS is the most beautiful thing in the world for me. Because I'm an old IP telephony guy and all this, and I fought the battles when we didn't have it, and I love it. Because now I can push my QoS all the way through here. I know how much bandwidth I got. I can put it through there and push QoS through there. But this is not encryption. We can encrypt it. We could do it at the router, or you could get it as a service from the service provider. But it's not natural in MPLS. That's a virtual private network. I have a friend who's a CCIE. He's done all these big networks, and he's been doing MPLS forever, it seems like. And his name's Stefan. He's Swedish. And he can't say the word MPLS. He can't. He says MPLS VPN. It's one word. He says it funny because he's Swedish. But he says it. MPLS VPN. In our minds, we think of VPN as secure and everything. It's not. And for our customers, when we start talking to them of the, financial institutions, healthcare institute, all this, we better be sure that we know what we're talking about. Because we're going to go in there and talk about moving voice and video and all this, that, and the other, and they're going to say, oh my God, that's great. We better consider security. Because I'm telling you, from now on, in the next 5 years, there's going to be more security breaches and everything that are going to drive more and more legal needs to secure all this stuff with telepresence and everything else. And that's going to be a bear. It's going to be a bear.
Why does it still have their own proprietary routing protocol?
Because we can lock people into our routers. Just kidding. Just kidding. Why? Because the open standard protocols were great. They were great, but it took a lot of processing power and all this, that, and the other. It took a while for them to converge. Again, these were standards and we could do them, but we thought there was something better. And what we did is we designed something better, and then we implemented it in our software better, and it works. And we're not going to let a standard happen. We're not going to turn that into a standard. And we want to do that. It's our intellectual property on how we came up with it. It's just like why Coke doesn't give everybody else the formula to Coke. We've got our own. We did it ourselves. And EIGRP is great. Now, a lot of customers say, I'd rather do OSPF. Well, yeah, Cisco router can do OSPF. Do as good as any other router. But EIGRP is our bucket. It's easier. It's easier.